class, and welcome to Math Minutes video lesson number 35. You will find this in your notebooks beginning on page 14. We're going to look at how to solve for systems of equations using elimination. We have already learned how to solve these by graphing. We've learned to solve them by substitution. Now we're going to look at how to solve by elimination. So let's get started. Turn to page 14. So here we are. The third method of solving systems of linear equations is to use elimination. Equations are either added or subtracted in a way that eliminates one of the variables. So if you look at our systems of equations, we're going to draw a line. And we want to get rid of the x's or we want to get rid of the y's. And we have a choice. If we add these two equations, will we get rid of one of the variables? Or if we subtract the equations, will we get rid of one of them? Well, if we added the x's, we would end up with 4x. So that's more. We're not getting rid of anything. But if we add the y's, we have a positive 2y and a negative 2. They'll go away. That'll become 0. So we will eliminate the y's by adding these two equations. So remember, your x really has like a 1 in front of it. So 3x plus x is 4x. We have 2 plus a negative 2 makes it 0. So that goes away. Then I have to add everything. So now I'm also going to add my 10 and my 6, and that gives me 16. Now I'm simply going to solve for x. I will divide by 4. That goes away. That gives me x equals, what is 16 divided by 4 is 4. I have solved for x, which means in my coordinate I have my x value to be 4. Now I simply have to find out what my y value is. I'm going to do that by substituting my x value into one of the equations. Now it doesn't matter which one, so let's do the top one because I don't want to subtract, and this is your choice. You can do either one. So let's substitute our 4 into the first equation. So instead of 3x, I'm going to substitute that 4 into it. So it's going to be 3 times 4 plus 2y equals 10. Now I'm going to solve for y. 3 times 4 is 12 plus 2y equals 10. I'm going to subtract 12 from both sides. That gives me 2y equals 10 minus 12 is negative 2, negative because I'm taking away more than I started with. And then I'm going to divide by 2, which gives me y equals negative 2 divided by 2. 2 divided by 2 is 1. But then when I have a negative being divided by a positive, my answer is negative 1. I now have my y value for the coordinate. So these two lines, when graphed, would intersect at the point 4, negative 1. Let's do some more practice together. Turn to the next page, page 15, and let's take a look at these two equations. 2x minus 4y equals 16. 3x plus 4y equals 24. Now, you get to decide which one, adding or subtracting, will result in zeroing out or eliminating one of the variables. If I add a 2 and a 3, I get 5. That's not eliminated. If I subtract a 2 and a 3, that's not getting 0. So let's look at my y values. I have a negative 4 and a positive 4. What would get rid of those? Adding them would get rid of them. So I'm going to add these two equations. I will get 2 plus 3 is 5x. My negative 4 plus 4 is 0. That's my whole point. I just eliminated the y's. Equals, now I have to add these two together, and that gives me 40. My next step is to divide each side by 5. X equals 8. So now in my coordinate, I'm going to make a note of that. I have 8 for my x value. I'm halfway to my answer. Now I'm going to substitute that 8 into one of the equations. Let's just do the first one. So over here, I'm going to have 2. Instead of x, I'm going to substitute my 8 in minus 4y equals 16. 2 times 8 is 16, minus 4y equals 16. Subtract 16 from both sides. Negative 4y equals 0. Well, now I divide by negative 4. I still have 0. So that is my y value. That means these two lines would intersect. If we were to graph them, would intersect at the point 8, 0. And let's try another one. 4x plus 2y equals 22. 2x minus 2y equals negative 4. Am I going to add or subtract in order to eliminate one of these variables? Well, I can't add or subtract to get rid of those, but again, I can get rid of my y's by adding. A positive 2 plus a negative 2 is going to be 0. So that's where my elimination is going to happen. 4 plus 2 is 6. I've eliminated the y's. What is 22 plus a negative 4? Really means 22 minus 4 gives me 18. I divide both sides by 6, and that gives me 3. So now I know my x value for this coordinate. I'll put it over here. My x value for this coordinate is 3. Now I'm going to put that into one of the equations. Let's use this one because it has smaller numbers. Doesn't matter which one you use. You can choose. So now it's going to be 2, but instead of x, I'm going to put my 3 in there. Minus 2y equals negative 4. 2 times 3 is 6. Subtract 6 from both sides. Negative 2y equals, what do we have here? Negative 4 minus 6 gives me negative 10. Now I'm going to divide by negative 2. That gives me y equals 5. 10 divided by 2 is 5, and because I have a negative being divided by a negative, my answer will be positive. So now my coordinate is 3, 5. If these lines were graphed, that's the point where they would intersect. Let's do one more together. I know. Let's try 2x plus 3y equals 20. X minus y equals 5. What are we going to do with this? Well, if I add these, I don't get 0. If I subtract these, I don't get 0. If I add these, I don't get 0. If I subtract them, I don't get 0. Well, here's where we're going to take a look at one little additional step that we get to learn. We can't, as is, eliminate either of these variables. So we're going to do a little step to help us along the way. And the step that we're going to do is this. What can I do to one of these equations to multiply it to make something eliminate? Now that sounds really confusing. Let me show you what I mean. I can take this bottom equation, and if I multiplied everything by 2, this would become 2x, this would become 2y, and that would become 10. Then I could subtract these equations and I would get rid of my x's. Okay, that's one way I could do it. Let's get it back to its original. Okay, that's probably the easiest way. Another way is to look at my y's. Well, this is like a 1 in front of it. What if I multiplied this equation by 3? Well, then I'd have 3x, 3y, and 15. If I do that, then I would eliminate the y's. So I can choose. Let's do this one since this is what I have written down. Let's choose to eliminate the y's. Okay, that means I multiplied everything by 3. So now if I add or subtract, what's going to get rid of those y's? I'm going to add, because by adding, I'm going to get 0 y's. So I'm going to add my 2x and my 3x, which gives me 5x. These eliminated. I'm going to add my 20 and my 15, and that gives me 35. I'm going to divide each side by 5. That gives me 35 divided by 5 is 7. Okay, well now I have a coordinate. I know my x is 7. Now I'm going to substitute that in to one of the equations. Now here's another little rule that we have to remember. If we have modified one of those equations, and by modifying, I mean changing it, right? And we did. We multiplied one of them by 3. So when I go back to substitute my value in, I can't substitute it into the equation that's been changed or modified. I have to substitute it into one of the original equations. So if we look at our page here, my choice is to substitute 7 into this first one because we did not change it. Or I'm going to substitute it into the second one, but back to the way it was. That means I'm going to take away the 3's that I multiplied by 4, and that becomes a 5 again. This was my original equation. Let's substitute 7 into the original equation. Well, instead of x, it's going to be 7 minus y equals 5. We can kind of see 7 minus what's going to give me 5. It's going to be 2. But let's show you the algebraic steps. We would subtract both sides by 7. That gives me negative y equals negative 2. Well, anytime we have a negative here, let's just multiply both sides by negative 1 because a negative times a negative changes it to positive but doesn't change the value. Negative 2 times negative 1 becomes positive, and there we go. It doesn't change the value, but we have flipped the signs. That means our coordinate, this is going to be a positive 2. When these two lines are graphed, they're going to intersect at the point 7, 2. Okay, so that is how you solve systems of equations by elimination. There's a lot of little steps, but it isn't anything beyond what we've been working on. But of course, we will totally be going over this in class and practicing even more. So keep up the good work, and I look forward to seeing you in class.